are not done. It's okay. Oh my, it's so small. So first, the math. Now, if this were a quiz, only the stuff in white would be graded. The other stuff is kind of helpful. It's just for your information, but only that stuff. And if I remember, I will change this to a helicopter because then I won't get any questions about how fast is the person moving at the beginning. So we're just really what I intended is to say we've got a person who steps out of a plane and then begins to fall. So their velocity in the beginning is 0 starting. But if it's a plane, you're not really going 0. So you really wouldn't know what the speed is. But with this helicopter, we know the speed's 0. So these are easy. The mass isn't going to change. 50, 50, 50, 50. And you could just draw a little line going down because they're all the same. The weight is mass times g, and g is 10. So 50 times 10 is 500. 500 newtons, 500 newtons, 500 newtons, 500 newtons, 500 newtons. And I'm going to put a minus here just to remind myself that weight is a downward force. So there are two forces acting on the skydiver. There's weight, and then there's drag, or air resistance, going the other way. All right, this first one, if there's 0 speed, then how fast is the air moving past the person? 0. So there's 0 air resistance. So this, which could also be called drag, this is 0. So we don't have any force. This is the only force. So the net force is what you get when you add drag and weight together. 0 plus negative 500 is just negative 500. Air resistance, the acceleration should be negative 9.8. And the other way to get acceleration is to use the triangle. Net force equals mass times acceleration. Or really, this is using Newton's second law. I'm just using a triangle to do the algebra. So acceleration is net force divided by mass. Yeah. In fact, I'm going to change it because we've been using negative 10 in here. It's a lot easier. So negative 10. Yeah. So if I wanted to use this equation, the acceleration equals the net force, which is negative 500, divided by the mass, which is 50. So negative 500 over 50 is negative 10. But you can also just know if there's no air resistance and the only force is your weight, then you're in free fall. In free fall, your acceleration is negative 10. So this next part, we've got a negative of 500 for this and 400 for that. So negative 500 plus 400 gives me what? Negative 100. Ooh, and Gianni, I think I might have missed something on yours. So that's negative 100. So now to get the acceleration, it's the net force, negative 100, divided by the mass of 50. What's 100 over 50? 2. So this is negative 2. Now, 72 seconds is a tricky one. But once you know the trick, it's actually easy. So looking at the timeline, 0 seconds the parachuter steps out of the helicopter. 20 seconds the parachuter reaches terminal velocity going 58 meters per second. 75 seconds the parachuter pulls the cord, chute deploys. So at 72 seconds, the parachuter is still going to be at terminal velocity at this speed. So that's 58. And if you're at terminal velocity, what that means is the drag equals the weight, and your net force is 0, and your acceleration is 0. So this is going to be 500. So the air resistance or the drag is 500. The weight is 500 downward. Add them together, you get 0. And if you wanted to use the acceleration formula, you would just do 0 divided by 50, which is 0. But that's what terminal velocity means. There's no acceleration. Velocity is not changing anymore. Until you change something, like you pull your chute, and then you make your area a lot bigger. Now you're going to have more drag, so this drag starts to increase. So now in this next one, the drag is 900, the weight is 500, 900 minus 500 is 400. And to get the acceleration, I take the net force 400 divided by 50. What's 40 divided by 5? 8. So 400 divided by 50 is 8. 8 meters per second squared. Now that's positive. That's accelerating upward. It doesn't mean they're moving upward. It just means they're slowing down really fast because they're falling. And then this last one, this is an easy one again. Why? Because we're at terminal velocity again. So this says the parachuter reaches a second terminal velocity of 4 meters per second, and that's at 80 seconds. So they're going to stay at that all the way until they hit the ground. So this is going to be, well, if it's terminal velocity, I can just write 4 meters per second, 0 meters per second squared, 0 net force, and this has to be 500. So at some point we'll have another quiz, and this is going to be unless I screw up and forget, this is going to be the first kind of question on the quiz. Any questions about?
Yes.
What's that?
How do you know how fast the thing goes from what it says on the thing? If the parachute gets deployed, how does that make it 58 meters per second?
So I don't know if I should, let me just talk about it and sort of point at this. So you step out of the plane right here, and then you fall faster and faster and faster. I'll draw this. I feel like I should draw things. So you're going to be, when you step out of the plane, you fall faster and faster and faster and faster. But at 20 seconds, you get to the point where your drag is just as big as your weight, and then you don't fall faster anymore. So you're at what's called terminal velocity at 20 seconds. And you go the same speed. So it says here your velocity is 58. So at the beginning, you're going 0. You speed up to 10 meters per second, 20, 30, 40, 50, 55, 56, 57. When you get to 58, you stop speeding up. And you stay there. You'd hit the ground going 58 meters per second if you didn't have a parachute. But at 75 seconds, you pull the chute, and then things change. So we don't know exactly what your speed is at 75, but you're going to start to slow down, like to 55, to 54, to 53, 52, 50, 40, 30, 20. That chute's going to keep slowing you down until you get to 4, and then it doesn't slow you down anymore. Then, again, the force of drag is equal to your weight. So now you're at a new terminal velocity. You just stay at 4 forever, or until you hit the ground. So these times that I'm putting in this square, we don't know what the velocity is between 0 and 20. And we don't know what the velocity is between, between 75 and 80. But between 20 and 75, we know it's exactly 58. And between 80 and 700, we know it's exactly 4.